our next speaker is an artist working with code, which is why we have not only the obelisk of doom, but also a computer. Yeah, that was a bit feeble, but all things considered, I'll let you off with that one. Yes, he's an artist working with code. Yes, that's what we like. He's a contributor to open source arts engineering toolkits like Open Frameworks, and he builds tools that let artists use algorithms in creative ways. So please go wild in a hot afternoon kind of a way, and welcome to the stage, Kyle McDonald.
Thank you for the introduction, and thank you to Ghislaine for having me here, and for Future Fest, and all of you for enduring the heat and the lack of real-time updates on the soccer game. Oh, football. Oh. My name's Kyle McDonald. I'm an artist based in Los Angeles, like you heard, and I'd like to share some thoughts and work exploring intelligence in the age of automation. I'd like to start with a question. How do you define intelligence? Just think about it for a minute. There's a lot of different definitions out there in literature. People have kind of folk definitions. Maybe what you're thinking of is something like IQ. Some people have more, but some people are average. We might imagine artificial superintelligence with a really high IQ. These slides were actually borrowed from the Japanese company SoftBank, so I don't really support this perspective. I think IQ can be a misleading way of talking about intelligence. The artist Edgar Degas said, "The day when people began to write intelligence with a capital I, all was lost." There's no such thing as capital I intelligence. One has a lowercase I intelligence of doing this or that. One must have intelligence only for what one is doing. I think we've seen some lists like this over this conference. Intelligence can mean a lot of things. When we say humans are intelligent, we're usually referring to a big collection of abilities or behaviors that we have. Things like constructing explanations, remembering things, answering questions, and so on. Intelligence isn't just one of these things, and it doesn't require all of these things. I'd say that each of these things is one kind of intelligent behavior. We also have an oversimplified idea of where intelligence comes from. We like to point to our big brains, but here's an MRI scan of a French civil service worker who had his head filled almost entirely with cerebrospinal fluid, and he didn't know anything was wrong until he visited the doctor. I'd say we even have an oversimplified idea of who is responsible for intelligence. Let's listen for a moment to the recording of this automated call.
Hi, I'm good. How are you?
Well, I'm calling about an online request you once made about health insurance coverage.
Okay.
I work with all major companies and compare...
Hey, are you a robot?
What? No, I am a real person. Maybe we have a bad connection. I'm sorry about that.
Oh, that's crazy. You just sound so much like a robot.
I am a real person. Maybe we have a bad connection. I'm sorry about that.
Will you tell me you're not a robot? Just say I'm not a robot, please.
I am a real person.
So it keeps going like that for another 3 minutes. Turns out it's true. They are a real person, but instead of speaking for themselves, they're pressing buttons that play pre-recorded messages. In a way, there's multiple intelligence represented here. It's a kind of composite system that is stretched over time and space from the original recordings all the way to this interactive playback we were just listening to. With this example in mind, I'd like to propose that intelligence can take many other forms and exhibit other behaviors than our narrow definitions usually provide. One weird kind of intelligence is found in a product called Mechanical Turk. Mechanical Turk is a system built by Amazon in 2005. It's a website where you can ask humans to perform small tasks for a small amount of money. For example, some of these tasks pay 1 cent to answer a question about a picture of text on a shopping receipt. These are tasks that are generally difficult for computers, but easy for humans. And there are hundreds of thousands of people doing labor on Mechanical Turk every day. You could call it a kind of distributed intelligence or a crowdsourced intelligence. Artist Lauren McCarthy used this crowdsourced intelligence to upgrade her dating life in 2013. For every day of a month, she asked Mechanical Turk workers to watch a live video stream as she went on dates. And she received feedback from the Turkers in real time. Things like, maybe talk about yourself a little less, or I think he's into you, don't worry about it so much. In this kind of situation, it can be hard to say whether the intelligence is best described as coming from each individual, or is the intelligence bigger than any single person. Around the same time Lauren was working on Social Turkers, I read a book by experimental French writer Georges Perec called An Attempt at Exhausting a Place in Paris. He sat on a bench in Paris for 3 days in 1974 and tried to transcribe everything that was happening, down to the smallest details. It reminds me a lot of Mechanical Turk in that it's a very human act of observation, something that can't be automated. For example, he writes, "The rain gets fierce. A lady makes a hat with a plastic bag marked Nicholas. Genevieve Sorrow passes by in front of the cafe, too far away for me to get her attention. Some green emerges from a shopping bag. The church square is almost empty. 3 people cross it. An apple green car, a 96 bus." He really loved noting all the buses. I was just starting to study machine learning when I read this, and one of the lessons in Perec's book is that it's impossible to avoid categorization. We like to imagine that humans are full of subtlety and nuance, but when we're caught in the moment, many things are lost. And what's not lost is significantly simplified. With these things in mind, I created Exhausting a Crowd with Jonas Youngyan. We recorded 12 hours of footage at Piccadilly Circus here in London and streamed it online with a tool that allows people to add notes to the scene. There's a few instances where it tends towards surveillance, like here where it says, "Car runs a red light." That's someone who left that note at some point while watching the video. It's a moment where the crowd of people using the website act as an extension of authority. With an access to an all-seeing eye, they can easily play the role of the police. But most of the time, it's surreal and absurd observations, like these bins communicating their true purpose. I'm actually a black hole sending rubbish to other dimensions where it's properly recycled and reused. Or this band who, well, I have no idea, really. It's this way, laddies. We shot from 3 p.m. to 3 a.m., and there's all these beautiful melancholy moments in the middle of the night, like these 2 people riding the bus creatively nicknamed by the advertisement outside. This is one of my favorite sequences. It was added very early in the project by a few different people. Each person added a few more notes on top of the previous one. So watch the couple walking in from the bottom right corner. And so then I says to Mabel, "Wait, look over there. Kiss me, you fool." "What? Gotta be? What, right here, right now?" "Yes, kiss me right on the lips." Couple kissing. How do I get her back to my apartment? "Do you think anybody's recording us?" Exhausting a Crowd's still online, and in 2015 we added another hour at a different location, so there's even more to explore. We keep going to new places and putting more footage up. One big lesson for me is that when you have a lot of data, it still takes humans to make a story out of it, to really understand it. And there's some data that only humans can make decisions about right now, but it might not be that way for long. So let's look at some examples of what machine learning can accomplish at the moment. A refresher, machine learning just means programming computers using examples of what to do instead of providing specific instructions or code of what to do. Machine learning is one specific approach to AI, but it's so powerful that sometimes people use these terms interchangeably. And the examples I'm going to give here are based on a machine learning technique called neural networks, or deep learning. If you have a bunch of example photos with labeled categories like leopard, mushroom, or cherry, neural nets can predict the category of a new photo from those examples as instances that it can learn from. When this research was published in 2012 by Hinton and Krzyzewski, it represented a major breakthrough, and this technique now powers a lot of products. If you have example photos with captions, you can train neural nets to predict captions for new photos. For example, in the center here, it reads, 2 hockey players are fighting over the puck. I want to give a quick demo of what it looks like for these algorithms to run in real time by showing an example of face analysis. So this is running in my browser right now. It's got one of these neural nets that's been trained on a huge collection of data, pictures of faces with the label of what emotion or expression is being represented by that face. So if I smile, then you can see the smile bar goes high. If I look surprised, because England just scored a goal, then that one goes up. Sad is difficult. Kind of gets more difficult the more rarefied the emotions are. Contempt. I can't get it to move. This is kind of just the beginning. Those like expression data sets are a very small subset of what's out there in terms of what researchers have collected. So maybe we have some more features we want to look at, like what's my gender? Am I Asian or not? Looks like I'm white according to this neural net. I'm not a child or a youth or a baby. Maybe youth is triggering the most. Black hair, it's got a little bit going on there. It says I'm frowning, but now I'm smiling, frowning. So this list kind of keeps going, and there's a lot of research out there about different properties that we can attribute to humans and ways that we can divide them up and categorize the world. And there's lots of scientists working at companies and inside governments trying to use this to do things like advertise to us better or decide whether we belong in jail or not. It's really kind of disturbing and potentially powerful. And if you came to any of the other talks, you might have heard some about the ethical implications behind these systems. But I wanted to show you this just to give you a feeling of like what it looks like to be kind of analyzed in real time by one of these systems that's been trained on a bunch of examples. I'm going to play an example of another recent application of these neural nets. It doesn't just have to be photos. They can work with almost any media. So I'm going to play a recording of Duplex, which is currently in development by Google. It's designed to call shops and ask for hours, schedule appointments, or place orders on your behalf. Duplex is designed to sound like a human.
How can I help you?
Hello?
Hello, what's up, man?
Hey, I wanted to know what are your hours for today?
10 a.m. to 6:30 p.m.
Okay, got it. Thank you for your time.
No problem, sir. Bye.
Unlike Samantha West, we heard earlier, this button pressing interface, it's not using any pre-recorded messages, and there's no human pressing buttons behind this. If you have a big collection of example phone calls, which Google has from offering free phone numbers to people for a long time and recording those messages, neural nets can predict conversations for new phone calls. They can also imitate speech from a specific person.
Neural nets can also imitate speech from a specific person. This is an example from a company called Lyrebird, spoken using my voice.
I'd say neural nets excel at imitation more than anything. In this example, a neural net's been trained to imitate the style of a painting. So in the top center, the net recreated photo from the left in the style of Van Gogh's The Starry Night, and you can see a few other styles represented there. And this research, the two pictures on the right were created automatically from the two on the left. So they generated a photo in the style of the sketch and a sketch in the style of the photo. Or you could say they generated a photo using the content of the sketch and a sketch using the content of the photo. Imitating style can be as complicated as this example. It seems like it should be difficult. Like this sort of thing should be impossible for algorithms to do. It should take someone who went to art school and studied a long time. But in a sense, every kind of imitation can be reduced to learning from examples, which we've developed some machine learning algorithms that are really good at that. Neural nets can also imitate text. In this example, an AI researcher named Andrei Karpathy trained a neural net on the collected works of Shakespeare, which is about 1 million characters of text. Reads from King Lear saying, "Oh, if you were a feeble sight, the courtesy of your law, your sight and several breath will wear the gods. With his hands and my hands are wondered at the deeds. So drop upon your lordship's head, and your opinion shall be against your honor." It sounds really like Shakespeare, even though it doesn't mean anything. And it would be even better if I had a proper British accent to pronounce it. This example is impressive because the net was never trained on any other text. It's only read Shakespeare. It doesn't know anything else about English, but somehow it still picks up some nuances of the English language, at least through Shakespeare's writing. With enough examples, short videos divided into different categories, neural nets can also imitate those videos. I really love these babies at the bottom right. They're super disturbing. I'd say these examples are really creative already, but because machine learning is typically used to power products like spam filters and music recommendation, advertisements, or face recognition, I think we can still get more creative. So I wanted to give a few examples of projects I've worked on. It turns out the same thing that makes machine learning good at imitation allows it to be good at understanding similarity. This can help us find connections in disconnected data. TerraPattern here is an open source tool I helped build, which offers similar image search for satellite imagery to help the public find patterns of interest and democratize geospatial intelligence. It's ideal for locating infrastructure that isn't usually indicated on maps. When you click on one container yard, it pulls up other container yards. It works just as well with cul-de-sacs or power lines or tennis courts. I also use search by similarity for my piece, Sharing Faces, to help friends find a connection across borders. We installed the same piece between Japan and South Korea, and when you explore the installation, it automatically finds someone with a similar expression and at their head in the same spot from the other country. I think this direction of machine learning in the context of relationships is equally exciting and scary. The philosopher Pierre Levy said, what remains after we have mechanized agriculture, industry, and messaging technologies? The economy will center on that which can never be fully automated, on that which is irreducible, the production of the social bond, the relational. It turns out, through Lauren's project, Social Turkers, I mentioned earlier, we actually started dating right afterwards. And 2 years ago, we got married. We've been working on art projects since we met, and I'd like to share a few of these pieces that fit this theme of kind of machine learning for social relationships. First, with man, woman in the middle, we wrote code to intercept all of our conversations whenever we send each other a text message and modify the messages before they get to the other person. We each created our own custom server to try and automate the best version of ourselves. For example, when I text, "I'll be there in 30 minutes," it says, "I'll be there in 60 minutes." Or if I haven't sent her a message in a while, it'll just say, "I'm thinking of you." We've both written dozens of rules and spent 6 months using this system, and one of the best things is just having the ambiguity of not knowing whether the message you got came from that person, or is their intention of who they want to be, or it's something else totally random that's a glitch. And it creates a very nice space for kind of taking them at face value and not taking anything too seriously. Second, with Us+, we created a system that automatically tracks your voice and facial expressions and gives you suggestions about how to have a better conversation.
Hi Claire, how's
Hey,
school
Mom.
treating ya?
I'm doing okay right now. I'm just kind of annoyed because there's this girl named Stacy in my yoga class who just got pregnant and she won't stop talking about it. And I just feel like she's being really...
Technology has made us more connected than ever. Shouldn't it help us get more from each other?
She just won't stop talking about her pregnancy and what yoga moves that the whole class should not do because she can't.
Us+ gives suggestions based on speech analysis and facial expressions.
No, it's just everything is... how are you doing, Mom?
Well, actually, things haven't been all that great. I wasn't sure whether to tell you this, but
More honesty, more balance.
I feel like we're barely communicating, and sometimes it's just not the same. I try to talk to you and you don't respond, and I can't even...
I love you.
It's been so long since you said that.
More connection.
It's looking pretty bleak. And our profit margins fell last quarter. But I think we can turn things around. If we outsource step 4, we should be okay.
We could also get it down 5 cents more if we use cheaper materials in steps 19 and 23, and the public will never know.
I like how you think.
More productivity, more success. Get more out of your conversations. Us Plus.
So this was a real app that we made. You could actually use it. It was online for a few years until Google took it down recently. You could just add it to your Hangouts. And I want to finish with one last project called People Keeper. With People Keeper, we created an app that uses a heart rate monitor to track how different friends affect your mood and automatically optimizes your social life.
We only have so much emotional bandwidth.
Bring it in.
And limited time.
Mustafa?
Our social circles are widening.
We don't know that's bad.
All those relationships
Anything in general that makes you excited. Just
can be overwhelming. Now there's an app. People Keeper tracks your physical and emotional response while you're hanging out. And it analyzes the data to identify who stresses you out, makes you excited, sad, or happy. See how your relationships stack up. And let People Keeper find the ones that work for you. It'll automatically manage your relationships, so you don't have to. Scheduling time with people that make you feel good. And blocking the ones that don't. Forget fake friends, failed romance, and FOMO. Optimize your social life with People Keeper.
So one of my goals in making this kind of artwork, especially this stuff with Lauren, is to create the space for reflection on the technologies in our everyday life and how they're affecting us and our relationships and society. I want to create a space for building an intuition for machine intelligence and automation. I think if we don't take the time to reflect, then we'll fall into the same traps as the past. Thank you very much for your time.